This is an idea that's used in the first semester of calculus. So we've got this function. It's an upside down parabola. And here it's crossing the y-axis at 4. It would cross the x-axis at 2 and -2. And the idea is find the area between that and the x-axis right here. So find that area in here. And we're going to use rectangles to do that. First of all, 4 rectangles. So we take this from -2 to +2, which is a length of 4. So take that length of 4 and divide it into, for this, 4 equal pieces. So for part A, so it's called delta x. The change in x is going to be, find the length of the interval, so subtract the two numbers, the big one minus the small one, divide it into 4 equal pieces. So that's going to be, each one is going to be a length of 1. So in other words, like this. So 1, 2, 3, 4 equal pieces. And now what we're going to do is make rectangles. So you go to the middle of this rectangle, go up to the function, and that's how tall the rectangle is going to be. So go to the middle of this rectangle, go up to the function, and then that's how tall that rectangle should be. Likewise right here at 1/2, go up to the function, and over here it's going to be symmetric. And then find the area of those 4 rectangles. So we could say take this, which is a -1.5, substitute it into the function, and then that's going to be the height, and the width is 1. So we would have negative of a -1.5 is squared plus 4. That is the height, and then times the width, which is 1. Next, take this value, which was -1/2, substitute it in the function. That's the height, and then the width is 1. And then do the same thing over here at 1/2 and at 1.5. So we're making a little series of 4 rectangles added together. And of course you could type this whole thing into the calculator and add up all the numbers, but there are a couple of faster ways to do it, which we're really going to need when we get to 1,000 rectangles. So one thing to do is you can look at the function (x² + 4), and I'm not really so interested with the graph, but instead make a table of values. So go to second table setup, starting at -1.5, and go by 0.5. On this one I can go over by 1, because I went from a width of 1. Okay, and then go to the table and it'll tell you all of these y values. So that means we've got 1.75 plus and then you can even see the symmetry that we saw here with the 4 rectangles is then right here with these numbers. And then add them up. So 1.75 plus 3.75 and then double it. So the area of those rectangles is 11 square units. There's another way that we can have the calculator do that, and that is under the list operations, put sum, which is here under math, and then go back to the list operations and go to operations, sum the sequence. So first of all, you need to tell it the function, which is negative x squared plus 1. That's the height, and the width is 1. And then just tell it the variable, which is x. And then the starting point of 1.5, negative 1.5. The stopping point, which was positive 1.5. So go from negative 1.5 to positive 1.5 in increments of 1. This is x squared plus 4. And then for part B and C, I'm going to have a different width than 1, so as sort of a placeholder, I don't really need a 1 in there, but I'm going to put the 1 just to say that's where the width goes. And then x goes from negative 1.5 to 1.5, and the area is 11. So then, now that we have this sum sequence, we'll be able to do these other two parts pretty quickly. For part B, the delta x is going to be the width of this thing is 4. And then divided into 10 pieces. So each one is going to have a width of 0.4. So that's what's going to go right here in place of 1. That the height will still be this, but the width will be 0.4 for each rectangle. Then where do I start and where do I stop? So the interval goes from negative 2 to 2. So if you move over by 0.4, if you move over by 0.4, that need a little more space. Negative 2 plus 0.4, that's negative 1.6. So that's going to be that first interval. But then we take the middle point and substitute it in. So it's starting right here in the middle of a negative 2 and a 1.6, so that would be at negative 1.8. And by symmetry, it's going to be over here a positive 1.8. So we'd have sum the sequence of negative x squared plus 4 is the height of the rectangle, and then a 0.4 for the width of each rectangle, and then x goes from negative 1.8 to positive 1.8 in increments of whatever this is, because each one is a length of 0.04, so each time we would need to move over 0.04. 0.4, excuse me. So I don't feel like typing it in again, so I'll just put second enter until I get it back. The width needs to be point and then insert a 0.4, and then this changes to 1.8 and 1.8 and 0.4. In the area, 10.72. So 11 was a decent estimate, but you can see that there's actually some error in there. And so this is a better estimate. Now do it with 1,000. So first of all, we'd have the width is going to be take the original length of 4, divide by 1,000. So 4 divided by 1,000, 0.004. So that's going to go right here, 004. And then if you cut that in half, so look at this one. If you take this and cut it in half, 0.2, then from the original starting point of 2, go over by 0.2. So take this and cut it in half, 0.002, and add that to the original left-hand side, which was a -2. So we've got sum, the sequence. Here's the height of each rectangle. Here's the width of each rectangle. And x is going to go from -1.998 to, by symmetry, +1998. And then second enter to get it back. This, I need to insert 2 zeros. This, I need to insert 2 nines. Insert 2 nines. And insert 2 zeros. Calculator's having to think about that one. It's adding up 1,000 rectangles right now. Oh no, I really didn't expect that to happen. That was too much for its memory. So what I'm going to have to resort to is go to the graph, and under calculate, second calculate, what we're doing is actually integrating, which is number 7. So tell it number 7, and for a lower limit, that's over here at -2, and an upper limit over here at +2, and it finds out the actual area is 10.667, so 10 and 2/3.